Here's kind of a simple example of a VPN technology. Remember, VPN is to virtually privatize information and extend it over untrusted networks, typically over the internet, to branch offices, regional branch offices, remote offices, teleworkers, remote access users, and the like. So typically the gateway is some type of VPN concentrator. It could be a server, it could be a router, it could be a firewall appliance, it could be a specialized appliance. So there's a wide variety of devices that can terminate and serve as a gateway. Often the gateway will also be its own certificate server, providing identity certificates for remote users and teleworkers, doing both server and client-side authentication, with the mobile device or the laptop presenting its identity certificate early on in the VPN negotiation process. And we have quite a few choices, and some of these choices are going to be vendor neutral. Some of the choices are more vendor specific. But for example, we could do an IPsec, IP security, IP version 4 or IP version 6. Remember, IPsec is native to IP version 6, although it's not turned on or initiated automatically. But you do have extension headers in IPv6, the authentication header extension, and the ESP extension. So we could do an IPsec site-to-site VPN between two endpoints, between two terminating devices, creating a tunnel. It could be a site-to-site VPN with pre-shared keys, or we could use certificates. And typically we use RSA certificates. However, we may be seeing more elliptic curve DSA certificates being used because of the popularity of elliptic curve or ECC. IPsec can also provide remote access VPNs between your concentrator or your gateway and end users, either installing some type of client like the Cisco AnyConnect client or the Palo Alto Network's Global Connect client, or it could be clientless, where they just use a supported browser and connect to the outside interface of your gateway for a basic VPN portal. Most likely you want to gravitate away from IKE version 1, Internet Key Exchange version 1, and gravitate towards IKE version 2, which supports Suite B cryptography. These settings in an older environment will be part of what's called a crypto map that's assigned to an interface, like the outside interface. For instance, here on our VPN concentrator, the public network interface 172.18.124.133. Or in newer Cisco implementations or on Palo Alto firewalls, you use a virtual tunnel interface. So basically, you just use your routing protocol, either static routing or dynamic routing, to route to the tunnel interface for your outbound traffic that must be protected. There's also dynamic multipoint VPN. Remember, IPsec natively doesn't support multicast. So we might want to use dynamic multipoint VPN, which uses GRE, which does support multicast and dynamic routing. It's a great solution to use if you're going to scale out and bring up new sites, new remote offices, where they could just simply create hub and spoke topologies or mesh topologies over a DM VPN cloud. As a matter of fact, if you're going to become a CCIE, you won't even do frame relay anymore. You'll do a DM VPN. There's also group encrypted transport, GET VPN, which is a tunnelless solution that commonly uses multi-protocol label switching and multicast and IP version 6 Anycast to connect to member servers over a GET VPN cloud. That's a very popular solution with MPLS and Metro Ethernet. Let's don't forget SSL VPN. So far I've been talking about IPsec and some of its extensions, some of its extensible framework options, but of course SSL VPN, which really today is going to be TLS, Transport Layer Security 1.1 or 1.2. That we could use a clientless solution where we just simply use a supported browser and create a portal on a gateway, or it could be client-based, the Cisco AnyConnect Mobility Client, the Palo Alto Global Connect Client. Both of these will offer plugins for different types of RDP connections, VNC connections, Citrix, other types of terminal service protocols. Metaframe, for example. You want to make sure that all of those type of remote access services are protected in a VPN. And of course, all of these devices are going to be protected using Secure Shell version 2 for secure management. Suite B cryptography, let's talk about that a little bit because that's something that you're going to have to deal with. We have the Suite B GCM 128. GCM is Galois counter mode, which is the preferable mode. If you're using ESP, you're going to use AES encryption with 128-bit keys with a 16-octet ICV or integrity check value in Galois counter mode. IKE can use AES 128 CBC. It can use its integrity with SHA-2 or higher authentication. It'll establish keys using things like Diffie-Hellman group 19 with a larger key size, and authentication using ECDSA 256-bit elliptic curve signatures. Suite B GCM 256 is going to use AES 256 and 16-octet ICV in GCM mode for ESP. For IKE, it'll use AES 256 in CBC mode, integrity with a SHA-384 HMAC, key establishment using Diffie-Hellman group 20, and authentication using elliptic curve DSA 384-bit elliptic curve signatures. So obviously you have to make sure that all of your participants in this site-to-site VPN or remote access VPN can support Suite B cryptography, and it may involve a hardware or firmware upgrade. Prime is basically protocol requirements for IP modular encryption. This is an IPsec profile that's defined for public sector networks in the UK, and it's based on Suite B cryptography, but it uses AES GCM instead of AES CBC for the IKE version 2 negotiations. This is one of the most important things I'm going to show you in this part of the training series, and TLS is used so much on the internet. I want to present to you what's called reasonably secure TLS. These are some great things to know for the exam, but also for the real world. So let's start off with the ciphers, okay? Let's only use 128-bit ciphers and higher, which means no triple DES, no 3 DES. We want to use suites with strong authentication. So that means elliptic curve DSA and RSA and elliptic curve Diffie-Hellman ephemeral, ECDHE. No weak primitives, okay? So no MD5 and no RC4, which is actually, according to the RFC, is illegal to run with TLS on your web servers anyway. We want to implement perfect forward secrecy, or as it's simply called, forward secrecy. Regardless of the protocols we're using or the strength of the keys we're using, we always want to use forward secrecy. Let's prefer elliptic curve DHE over RSA if it's a dual key deployment. With TLS version 1.2, let's have our clients prefer AES GCM, which we just saw is part of Suite B cryptography. You want to remove things like DSA, pre-shared key, SRP, elliptic curve Diffie-Hellman, the legacy version, IDEA, SEED, and Camellia. Those should be stripped away from the profiles on your web servers, so they're not even presented to the clients as an option. We want to implement HTTP strict transport security if possible. HSTS is basically concerned with 3 types of threats: passive network attackers, active network attackers, and imperfect web developers, and there's tons of those out there, okay? We know that just from the whole OpenSSL heartbleed bug we saw a little while back. Basically, your website is going to declare its support for HSTS by having strict transport security in the HTTP response header field, or there could be other ways. In other words, you could configure the client in a user agent configuration. But basically, we're enabling websites to declare themselves accessible only through secure connections, or for users, maybe corporate users, who want to be able to direct their user agents only to given sites. So maybe using a combination HSTS and certificate pinning would be a great thing. Certificate pinning, maybe also consider DNSSEC, DNSSEC, looking into that as well for your corporate participation. And let's store all those private keys on some type of HSM or micro SD HSM. There's 2 or 3 really good vendors up there on the internet. Okay, let's take a look at a demo of configuring a clientless SSL VPN. And the great thing about a clientless SSL VPN is that you can start out clientless and do what's called web launch, and you can download or you can install on your client the agent that you need, either persistent or non-persistent, so you can use the clientless web launch option to actually pull that client down from your gateway. It's a very common solution, so let's see how it's configured on a Cisco device. Okay, in this demonstration, we're going to look at the use of a clientless remote access VPN, which means there's no client software. There's no VPN agent software installed on the endpoint. We're just going to use a supported browser like Internet Explorer or Mozilla, and we're going to be going from the Internet PC down here at the bottom, and we'll be using as our gateway that ASA that I'm pointing to right there, Site 1 ASA. As far as a use case goes, there's lots of reasons to do this. It can be the method that you use for your extranet partners or one of your customers or your vendors, or it could be a fallback method for somebody who's usually using some type of client software on their laptop or their endpoint, but they need to get temporary access. So we're going to go ahead and log on to the ASDM here. And we're going to go to Wizards, and we're going to go to the VPN Wizards, and we're going to choose the clientless SSL VPN Wizard. Here you see your scenario over there. It's a browser-based solution going across the untrusted network through an SSL gateway, which is really going to be a TLS gateway, I think in this example 1.1. We're going to be doing a connection profile, also referred to as a tunnel group. So let's go ahead and call this clientless access. And then we're going to be terminating this in the outside interface of this appliance. We've got our certificate loaded for TLS. You can see also at the bottom the URLs that the users need to put into their browsers. These are private, these are not routable, but this is a lab environment. And again, you can see the URL for the admin access as well. In a real world environment, these would be publicly routable, like 99 dot something. You can also create a connection group alias that you could type in there, and we'll do that. We'll use clientless access and click on next. Next, we need to authenticate, and we can authenticate using a AAA server group, for example, like LDAP or something else, but we're going to authenticate with the local database with the user admin, and we could add users here. These would be stored locally on the appliance, and again, we could use Active Directory, we could use other methods. Clicking on next and going to creating a new group policy. And this is basically all the features that we're going to add once we get authenticated. Okay, so once we use our tunnel group or our connection profile, this clientless policy will apply. Bookmarks are interesting because these are methods that we use to kind of customize the portal. So we can manage bookmarks and put hypertext links for HTTP, HTTPS, CIFS, and FTP. So we're kind of controlling the visibility of that web interface. Click on the Manage button here. We can go and add. We'll make a bookmark list. And then, see, we'll name our bookmark list clientless bookmarks. Add. And we have several options to create these. We can use a URL with the get or post method, but we're going to choose that option. We're going to call our bookmark Site1 Web. And then the URL is HTTP. The drop down there shows 4 options: HTTP, HTTPS, FTP, and CIFS. Make another bookmark, Site1 FTP. You can see we'll use FTP there. Put in the URL address, 1.20. Click on OK. Now we have a couple of bookmarks, Site1 Web and Site1 FTP. And those are going to show up on the portal when the clientless user logs on. Click on OK. Here we could customization objects are a way to customize that portal. VPN group policy enforces this, or the Cisco dynamic access policy, or an individual user could have their own policy. So this is a way to, you could import XML, for example, and you could customize the graphical interface, totally brandable portal. Or you could export the default and then go ahead and modify it, as some platform, some web development platform, and then re-import. Click on OK. You can see our bookmark list, and here's our final features for our SSL VPN, or more accurately, transport layer security. And we're using local authentication. We're not using Active Directory or LDAP or Radius or anything like that. Just a basic group policy that'll apply to this connection. And all the user needs is just a URL to put in their address bar. Here are the commands that are going to be pushed over to the appliance from our management station. Notice that it's the web VPN keyword. So web VPN is what Cisco's historically used, but it's also used by other companies as well. So they don't market this as web VPN anymore. They market it as SSL TLS or SSL VPN. And you can see we're using tunnel groups, which is another word for connection profile. Okay, back in our diagram here, we can see we've got our adaptive security appliance, which is our head-end gateway. Let's go down to the Internet PC and access Internet Explorer. And we're going to type in the IP address to the gateway, vpn.site1.public, or the qualified domain name. You can see down there we're going to use the clientless access group, or that's our tunnel group or connection profile. And we're going to log on. Again, this is going to be against the local database on that firewall appliance. And so the client side here is going to be using the password credentials, but there'll be server-side authentication done by this browser. Notice also if we had other connection profiles, for example, if we actually had some type of agent installed on this laptop, we could use the remote access connection profile and use the VPN adapter. So we're going to log in as admin, and then there's our kind of customized portal. You see our web bookmark and our file folder bookmark. This visibility is completely customizable. And by the way, we could change the logo to, Brio Insurance Group if we wanted to. We could change the name of SSL VPN service to TLS or whatever we want to call it. And we can control whether they have an input bar, whether they have a browse button. We can control web applications. And this is also a place where we could have Cisco plugins for things like Citrix and VNC and RDP, for example. Also realize that this is visibility, not security. If somebody really knows, how to get to an asset in the DMZ, for example, or in the internal network, they could go up there to this address bar and just type it in, because you can see with the plus CSCOE that we're doing URL rewriting. So this is a VPN gateway serving as a proxy. And so to do real security, I'd have to have what's called a web ACL or a web type ACL. So just because you don't provide links to certain things on web servers and FTP servers and CIFS doesn't mean you can't get to them through this portal. You could use the address bar and you could bypass security. So we have to include in the group policy, we have to include a web type access control list. And that web type ACL is a little bit different. It uses permit statements, and you're basically permitting or whitelisting HTTP, HTTPS, and FTP and CIFS. So now we're looking at the FTP server. You can see that we've got a bunch of directories there, a bunch of buttons on the top where we can actually do FTP management, the double arrow, the globe, all different types of functionality for FTP. Back over on the firewall dashboard, let's go to the monitoring, and let's monitor our VPN. Go to VPN statistics, and then down to sessions. We want to filter out our sessions. We see we have one browser session here, by the way. We want to filter out our all remote access. And here we see our user, admin, our connection policy and connection profile, the IP address, the public address. Notice we're using RC4, which this is a good chance to tell you that you shouldn't be using RC4. Okay, RC4 is actually illegal according to the RFCs on public servers. So, we should be using AES 128 or AES 256 at least for our encryption. Our hashing should be using SHA-2. Encapsulation should be TLS version 1.2 or higher. Okay, so, this is a lab environment using more basic connections. On the internet, we definitely want more robust security. So there's our logout page. So we have a logon page, we have a portal, and a logout page, and all of these things are customizable, brandable. Let's go back over to the ASDM tool. Let's go to configuration, and then show clientless SSL VPN access. That's the area here where we have our connection profiles. And if we scroll down there, we'll see that clientless access is our connection profile. It's enabled, it's checked off. and we're using local AAA. You also see here other connection profiles like remote access. That's actually the full tunnel Cisco AnyConnect client remote access connection. So that's going to actually be using an agent software that's deployed to the laptop. It shows up here in this area, but this is not actually where we would enable it and activate it. Okay, we are still in the clientless SSL VPN access area under connection profiles. If we went back up to network client access and then went to AnyConnect connection, that's the area where we would go back and reconfigure or configure for the first time the remote access full tunnel VPN using the AnyConnect client from Cisco, their mobility client. And so that's using SSL TLS and IPsec. So that client can support both TLS VPNs and IPsec VPNs. A couple of other things here that would apply to both the full tunnel remote access and the clientless VPN would be the certificates. So whatever's in the device certificate area or the port settings, that's going to apply to all of your remote access VPNs. Anything you have in the device certificate store will be available to all those VPN options. Sometimes you'll see port settings. Some companies will get off of port 443. If you wanted to get off of port 443, as long as the client and server can agree, you could get off of that port and use something different, some ephemeral port. And again, it would apply to the clientless connection profile and the client-based. Here we see the connection profile. We see the name. We see that we're using local AAA. We could use certificates in both. We have a group policy, and that basically applies to everything after we get connected and authenticated locally. Okay. We probably want to also set up DNS while you're here. You want to go to the Manage button and do that as well. Click on the Manage button there, and we can see how we can edit the clientless policy that we're using, and it's basically a child object of the group policy. Okay, so it inherits anything that you would set up in the default group policy. We don't like to use the defaults, but remember that it does inherit any settings in the default group policy. So cancel out of here. I'm going to go down now to the portal area, and under portal, we're going to go to customization. And here's where you have your customization template, where you could take the default customization and export it, and then let your web developer totally customize it and import that template back in. You have the option to do that. And we're just going to go ahead and use a wizard here to make some customizations to our portal. And if we go and take a look here, we can go to the title panel, informational panel, the copyright panel. All these things can be customized. Your portal page. Here's your portal page title panel and the toolbar. You can display the toolbar or not. You can see your applications. There's MetaFrame, Secure Shell, Telnet, terminal services, all types of things we can create plugins for. And we can add those plugins. Now, this is just adding the buttons for it, but we have to get the plugins from Cisco. Let's change the name of our particular portal to Site 1 Clientless SSL VPN. You could also upload a logo there. So if I wanted to upload the big Brio group, I could do that. I'm going to change my font to bold and my font size, make it 150, and change my font color to blue, maybe light blue. Also, I could use cascading style sheets. I could leverage that web developer and really go to town on this clientless portal if this is a permanent solution, okay, for a vendor or a large customer or maybe some teleworkers. Notice down at the bottom, this on-screen keyboard area, you can choose not to show it on-screen keyboard, or you could provide it for the login page or for all portal pages that need authentication. That's kind of a countermeasure against keystroke logging or key loggers. By using an on-screen keyboard, it gives us an extra layer of security there. So that's an option for you to keep in mind. Let's click on Apply. Here's the sending the commands over to the appliance. Let's go see the results. I'm back over on the Internet PC out there in the Wild Wild West. HTTPS And then there's the FQDN VPN site 1.public. And then there's our basic portal. Type in our username and password. And then voila, you can see our changes. Site 1, Clinus SSL VPN. In bold, it's blue, it's bigger, 150% bigger than we saw before. And again, we could have our Brio Insurance Group logo there, and we could have a bunch of other bookmarks and for web, for file, for CIFS. We could also have buttons for different plugins, for RDP, for example, or other things like that.